Hi guys, this is Shasyam. Currently, I'm a student who's pursuing computer science, engineering, and artificial intelligence at Sri Venkateswara College of Engineering. Today, I'm here, you in front of you, in order to present you and provide you the basic information about the ACID properties in NoSQL. The ACID defines as that A stands for atomicity, C for consistency, I for isolation, and D for data. This presentation explores the concept of ACID properties in the context of NoSQL databases. We'll cover what ACID properties are and how they are handled in NoSQL. The NoSQL is preferably determines the meaning that where there's no structured query language is being used and the trade-offs which has been involved. The introduction to the NoSQL databases beyond relational. NoSQL databases are a type of databases that does not adhere to the traditional relational database model. They are designed for scalability and flexibility. Okay, now let us focus on flexibility. They are optimized for large data sets and can handle a wide range of data structures. Unlike traditional relational databases, they're often used for unstructured data, such as social media posts or sensor data. And what are ACID properties? Okay, the ACID properties, as we said, as we talked before, A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. All these four combine in order to form an ACID properties. Therefore, now let us go through every single point that derive the meaning of ACID. The first one comes to atomicity. A stands for atomicity in the ACID, where atomicity determines that all operations within the transactions are completed or none of them are completed. They ensure that in order to ensure to provide 100% reliability and efficiency and accuracy of the work that is being done, or neither no work has to be done. Now, when we move to the consistency is a word that defines that where tells that when a task is being processing or a task has been undergoing, where the process must ensure in order to continue even there's a failure or even there's an external factors that affect the process. As says that the data remains in a consistent state after a transaction is complete. When come to the isolation, the transactions are isolated from each other, ensuring that they do not interfere with each other. The durability. The durability changes made by transactions are permanent, will not affect the event. Now, atomicity NoSQL. The strong atomicity and eventual atomicity. All challenges within the transactions are completed on all servers, ensuring the data is consistent. This determines the meaning of strong atomicity. The eventual atomicity. Changes may not be applied immediately to all servers, but are eventually replicated to all servers. This is what defines the meaning of atomicity NoSQL. Now the consistency NoSQL. Therefore, the strong consistency and eventual consistency. The strong consistency. All clients see the same consistent view of the data, regardless of where they are connected. When eventual consistency, data may not be consistent across all servers immediately, but it will eventually become consistent. The isolation in NoSQL, where it can be classified into read committed isolation and snapshot isolation. When we go to the read committed isolation, transactions read the latest committed data, preventing dirty reads. Means it's going to provide us the meaning that where the transactions means where the data fetching operations or data updating operations where which helps us to read the latest committed data, preventing the dirty reads. When the snapshot isolation, each transaction operates on a consistent snapshot of the data, ensuring that they do not. Okay, therefore each transaction operates on a consistent snapshot of the data, ensuring that they do not interfere with each other. Now let us go to the durability NoSQL. The durability means how long, how efficient, how accurate is the process in NoSQL. write-ahead log, and replication. In write-ahead log, changes are written to a log file before being committed to the database. When these log files are the part of a computer or in the form of NoSQL, where these log files are going to store all the security operations that have been stored, or all the changes, what the modifications have been done through the process. It provides a brief detailed view about that. The replication means the data is replicated to the multiple servers, ensuring that data is not lost if one server fails. It usually uses the right configuration where the data has been stored at multiple locations, even though if a single location or multiple location failure occurs, where using the right configuration method, the data can retrieve. Handling asset properties in NoSQL. It can be done by using three methods: gap theorem, base, and design patterns. The trade-offs of asset in NoSQL. It can be determined by the performance, scalability, and flexibility. And the last one is NoSQL database design considerations, where data model consistency needs and performance requirements. So thank you for providing all your valuable time in order for hearing this presentation. I think this presentation will provide you a basic and valuable information about a NoSQL, sorry, asset properties in NoSQL. Thank you.